So what I'm going to be showing in today's video is going to transform the way you think in electronics. So let's get started. So in this video, we're going to be thinking different outside the box when it comes to building a simple night activated sensor switch. I'm telling you, in this video, this is going to be a different video you have never seen on YouTube or maybe in any other website. Maybe you've come across something like this, but I haven't seen it, or maybe on YouTube or maybe on any other website. I just have that knowledge of trying something and it worked. So you're going to learn on YouTube or maybe other websites. You have noticed when it comes to building a night activated sensor switch, they use transistors like the MOSFET or maybe the BJT. But maybe some of them have to use an op-amp like this, like some of these components like the op-amp, or maybe using a 55 timer IC to achieve this result. But in this video, we're going to be thinking completely different. We're going to be using an electronics component that has just two legs, but it still functions like a switch, but it's still an active device. But the question is, which electronics component has two legs but still functions like a switch? Unlike the basic way of building a simple night activated sensor switch using an LDR in series with a resistor forming a voltage divider bias method at the base of the transistor. So whenever the base voltage threshold for the transistor is reached, usually from 0.6 to 0.7 volt, when the LDR senses the darkness, the transistor is now switched on to turn on the LED. That's the LDR has changed its resistance value due to the light difference in the room or the environment. But how is that supposed to work with a component with just two legs, which is the Zener Diode? Yes, you have been taught that a diode allows current to flow in one direction and blocks currents coming in the reverse direction, and also that a diode will perform well when used in the forward bias form, but when used in the reverse bias form, it won't really perform well. But yes and no, because a Zener diode actually works both in the forward bias form and the reverse bias form. But I won't be going into that in detail in this video. So this Zener diode I have is rated at 3.7 volt, and this is its threshold reverse voltage, which means any voltage between 3.7 and above will successfully get across the diode, and any voltage below its rated value won't get across it or will block any current from passing through it. So you should get the idea where this video is driving us to, which means in order for a Zener diode to work, it needs to be used in the reverse bias form. I tested the value of my LDR resistance value with my multimeter when there was a complete darkness in the room and low light in the room and full light in my room. At complete darkness, the LDR value was 10 mega ohms. At low light, the LDR value dropped to 51 kilo ohms, and at full light, the LDR dropped to 1.2 kilo ohms. So let's see how this varies with the voltage I will be using. So I have a power supply here which is rated at 5 volts, and this is what we are going to be using to test our work. You should also remember that using a 3.7 volt battery like the lithium battery won't work perfectly for this circuit, because the Zener diode is already rated at 3.7 volt, and the circuit is going to have a voltage drop, which is not going to reach the requirement for our Zener diode, which is going to be enough for our current to pass through the diode to turn on the LED. So when using a battery, you should use a battery of around 4 volt or 5 volt and above. So let's test the circuit. Oh, do you know I just forgot something? What did I just miss? If you're watched to this point, and I'm sure this video is already getting interesting, but wait, if you haven't hit the subscribe button, you're already missing out. So hit the subscribe button for more videos coming up. And you want to see me also next time, so you have to hit the subscribe button and also keep your notification bell on, so that YouTube is also going to notify you each time I do upload a new video. So let's get back to business. And here we have a multimeter which reads the output of our circuit. And if I block the light from hitting the LDR surface, we can see a change in voltage at the output. And what if I place an LED? I'm sure this should work. So I will simply do a demonstration by turning off and on the studio light. And here we go, the circuit worked pretty much as we thought. And you can see how the LED responds fast due to the changes of the light. So actually, the project actually worked. You know, I never expected a Zener diode to work just like a diode would do the job, and it did that perfectly. So, oh, is that this great video, should I say? but it's a kind of good video, yeah. But you know what to do. You always know what to do. Make sure to hit that subscribe button if this video really make more sense to you, and if this video was inspiring, you also know what to do. Like, comment, and also share this video with your friends. When I mean comments, I want to know what your thoughts are about this video, and also what other video would you like me to make about electronics. You know, we are intellect. So see you next time.